Hey everyone, welcome to the third workshop. I'll just wait a few more minutes to allow more people to join. Okay, I'm going to make a start, and hopefully more people will join in a moment. So I'll share my screen. Okay, so yeah, you can see that. Okay, so welcome to the third of these workshops, third and final one that I'll be doing. There's plenty more workshops for you to do though, so yeah, please do carry on with those. What I'm going to talk about today is the thing third part here. So this we're going to look at some common patterns, and we're looking at account abstraction, which is a very important and useful feature that we have on StarkNet. We'll then look a little bit more at DeFi development. We started to look at this last time, so I'll continue with that, and then we'll look at game development. But before I do that, what I want to do is talk about the onboarding task. So this is a task for all of you to do, and there's a link here to give you details about that. So let me switch to that. So it's a, a very simple, yeah, it's a very simple task for you to do. And what you need to do is to write a Cairo contract and then deploy it onto the Goerli test network. Once you've deployed your contract, you need to register the contract address so that I can see that you have completed that. The things you will need for this is that you will need a wallet because you're going to be interacting with the test network. So you need to get a wallet set up, such as Argent or Bravos. And you'll also need some test ETH, which you can get from the faucet. And I think I've been through all of that before, so you shouldn't have any problems with that. So that's what the task is about generally. You need to write a contract, deploy it onto the test network, onto the Goerli test network, and then register that contract. And I'll show you how you can do that in a second. But let's talk about the contract that you need to write first of all. So it's a extremely simple contract. So I haven't made this difficult. There's no sort of tricks to this or sort of no hidden parts to this. It is very simple indeed. So it's a simple voting contract, and in fact, it's you're voting for just one proposal. So there are no options. It's just a case if you vote, then we want to be able to record your vote. So within your contract, you need to have a function called vote, which people can call to show that they are adding their vote. So they don't get a choice about a proposal. There's only one proposal. So they just call this function to vote. And what you need to do in the contract is just to keep track of the number of votes that are have been done. Um, sorry, let me post that again. Okay. So yeah, you just need to keep track of the number of votes that have been cast by people calling the vote function. So very simple indeed. Now the contract itself needs to implement the following trait. So I've showed this is the trait here to show you the functions that you need to implement within your contract. So you need to have a vote function, which is going to change state and allow you to update the number of votes that have been cast. And then there's a get votes function that is a view function, which is going to return a number, felt 252, and this is to display or to bring back the number of votes that have been cast so far. So a very simple contract. The only other thing you need to add is that if someone has voted once, then they're not allowed to vote again. So you need to have a way to prevent people from voting more than once. So, and this can be based, the identity of the person can be based upon their address. So the address from the of the sender of the transaction. Okay. So uh, and also, when somebody votes, you should also emit an event to show that a vote has happened. You don't have to put any other information into that event, but just an event has to be emitted to show that a vote has been cast. So it's very simple contract. You don't need to put any security around this. You don't need to limit who can vote or who can see the number of votes cast or anything like that. It's an extremely simple contract. I tried to make it simple. It's really just there to make sure that you can write a simple contract and deploy it onto the test network. All of which we have done. I mean, in the first workshop, we went through all of the things you needed to install to interact with the network and to write contracts. And we had some examples. I showed you examples of doing that. So you shouldn't have any problems doing that. Okay. If you have any questions about that, then please do ask. Probably best to ask on Slido. Oh, the other thing to be aware of is the deadline for this. This is the from the document, the hackathon document. So the deadline is the 27th at 1700. So you've got a couple of days to write the contract. Now, the I said that you, as well as writing the contract, you need to register this. So after you've deployed it, obviously it's going to deploy to a particular address on the test network and be available. And then once you've done that, I want you to what I've called register this contract. Now, the first part of that is that I want you to uh, transform your Discord ID to a number, so to a felt 252. And to do this, it's quite simple. You just need to go to Voyager, the block explorer, and you'll see that there is under developer there are utilities, and there's a number of utilities you can use there. One of them here is the short string to felt, and so what you can do in there is put in your name, and this will give you a felt output. So it's converting the short string to a felt output, as you can see there. So you'll need that number. So go into the utilities, put in your Discord ID, and get the number, the felt value for that ID. Okay, so that's the first thing you need to do. So that's all written down here. The second thing then you need to do is to go to the registry contract, and this is where you're going to register your voting contract. So I've put the address there, and it's linked as well, and it is this contract here. So you can go to this in Voyager, and what you can do is, I mean, you can use Voyager to interact with contracts. So once you go to that contract, you can go to the write contract tab here. There's a number of tabs at the bottom, and you will see that it brings up first of all, it will be like this, but it will bring up this function register contract. And what you need to do is to call this. So the the arguments you need to pass in the first box here, you need to put in that number that you just worked out from the utilities. So this is the number corresponding to your Discord ID. And then in the second box, you need to put in the contract address of the contract that you have deployed. This is your voting contract. Once you've put both of those in, you need to you need to connect your wallet, and then you need to hit transact. You need to confirm the transaction in your wallet, and then that's everything done, because that will then send an event for me so that I can see the details about your contract. Okay, so that's all written down here. I think that's really obvious, straightforward. But if you have any questions, please do ask. The You can ask on Slido, or you can ask on Discord. Yeah, I think it's really straightforward. But that's the task, and I'll go through this again at the end, because I think there'll probably be some people who haven't joined yet, so I'll go through it again later. All right, so that's the onboarding task. So let's go through the other details. Another item that I heard about this afternoon is that there's going to be some stress testing on the network, on the test network on January the 30th. Just to make you aware of that, if you're going to be using the network, it's likely to be somewhat slow because they're stress testing it. So be aware of it. All right. Uh, okay, I'll keep putting there you go. All right. So, okay, that was the onboarding task. So I've just gone through all that, so I won't go through that again. Okay. Okay, let's talk about some common patterns or just useful things in Cairo. There is an appendix within the Cairo book. I mean, the Cairo book itself is very useful. There's a lot of information in there, lots of examples. So it's worth having a look through that and having a look at the examples. And then in Appendix C, there is here you can see there is a list of some useful traits that are available to your oh, I think okay, am I not screen sharing? Hmm. Yeah, I think I am. Let me just yeah, that's I'm definitely screen sharing. Uh, okay, thank you. So yeah, the in Appendix C, there are a list of things that are available to your contract, and some of the most useful ones are things like getting the contract address. So you can see here we have a couple of examples of getting the caller address, getting the contract address, etc. So yeah, have a look at those. And I got you an example here. If you wanted to use those, you can import that particular function, and then if you wanted to put the caller address into a variable, you can do it like this. Now, as in addition to those useful uh, pieces that are available to you, another thing to look at are the Open Zeppelin contracts. So these are a I talked about these briefly, I think, on the first workshop. I'll just talk about them a little bit again, because you should try to use it as much as possible, because these have been well written and it saves you a lot of work. You don't want to reinvent the wheel. So rather than rewriting any of this, try to either directly use these contracts or extend these contracts in some way. And they provide a lot of the type of functionality that you're probably going to use within within most common use cases. So things like if you want to create a token, you've got the common ERC20 token here. the common fungible token. There's the ERC721, the non-fungible token. So they're slightly more complex. But also you have things such as access control available, as you can see here. Details about account. We'll come to, well, this is going to be account abstraction, so I'll talk more about this actually in a moment. Security as well. So lots of useful things in the useful things in utilities as well. So have a look at those. And just wanted to go through some of the uh, details of this. So if you have a look in GitHub, you can see the types of things that or the way that these contracts have been written. So, for example, if you look at the ERC20 contract, you can see the type. This is done in components, and we saw components um, uh, last in the last workshop. But this gives you an idea of how this is being done in Open Zeppelin for the ERC20 contract. So they've made this ERC20 component, and because it's a component, this means that you can, this is meant to be reused in other contracts, so you can use this yourself. But you can see here the types of things they're doing in the storage, and I think I put this in the notes as well because they've got details. You can see here the name and the symbol. These are represented as felts because we don't have strings as such. So these get converted into felts. We have a total supply of a U256 because that then is the same data type that we have on Ethereum. So we're getting some commonality there. Of course, that data type is larger than a felt 252, and so this is a special data type that is split up. And you saw this in the notes from workshop one. We saw how they go around making that, creating this particular data type in two parts. And then if you're familiar with the ERC20, you'll understand that how we hold balances of tokens, in that we do it as a mapping where we have a mapping between a contract address and a number. So here we have a mapping between a contract address and a U256. So this means for that particular address, there is a balance of a certain amount, and that's going to be a U256. Okay. Um, all right. And then in terms of allowances, it's a little bit more complex because an allowance you have two addresses because there is an address for the person who is the original owner of the tokens. And then there is an address for the person that they are delegating to or they're giving an allowance to. And then the U256 is the number of tokens that they're allowing that person to spend on their behalf. Okay. So I just wanted to go through and show you some of the common types of structures that you may use. Okay. There's also and other details here of events as well. So you may want to have a look at those, or you can look in the notes or in the Cairo book to find out more about that there. Okay, so that's the details from Open Zeppelin. Yeah, I mentioned the legacy map there. So yeah, this legacy map, you saw the details. Just generally, if you want to use it, it is a mapping between a key value pairs. So you can see here, you could use it to map between an address and a Boolean, for example. And then you use these methods to read for a particular key or to write to a particular key. And then there's details from Open Zeppelin again. Okay, so let's talk about account abstraction now. So this is a recent improvement on the way that accounts are being handled on blockchains. And it's when Ethereum was invented, it was quite a long time ago, and it was done in a certain way, and it was very much the accounts were very much tied into the way that signatures were being done on Ethereum. It was a very simple model, but it didn't have much flexibility. It didn't have much functionality. It was really very much tied into your public and private key pair that you would have, and there was the on Ethereum, you have the possibility of externally owned accounts. So this is just the sort of the normal wallet account, or it could be a contract account. And um, uh, yeah, the externally owned accounts, the usual accounts, these have a public and private key pair. And when we do a transaction from one, then we sign that with the using the private key. And then there is a way that this can be uh, checked in the Ethereum virtual machine. And the contract accounts are different because they don't have a private key, and so they can't create transactions themselves. Okay, so that's the sort of the where we are on Ethereum at the moment, and this is sort of how it was. But this has all sorts of limitations, and so we don't get the choice of the signature scheme that we're using within Ethereum. We have to use the standard one. Um, it's not quantum resistant. We don't have any support for social recovery, uh, and so it is all quite inflexible at the moment. And when people looked at this, and when people started to think about creating layer twos and creating other blockchains, they started to reinvent and to rethink how accounts were being handled and to work out ways that this could be done. We could add more flexibility. We could add more functionality to all of this. And there's some links here if you want to read through this about some of the ideas that came up, giving some details about this and the different pieces of functionality that this brought. Or these proposals have brought, and there's a talk about this. But what was realized was that as people started to create layer two solutions and layer two blockchains, such as Starknet, they didn't have to design accounts in the same way that Ethereum had done it originally. They could do it in a completely different way, and they could do it in a much more flexible way. And this became known as account abstraction. And so what we have generally is that most of the layer two solutions out there have done their own version of account abstraction. And Ethereum is trying to move towards that, and it has some support for it already. Um, but it is more difficult to sort of retrofit this into Ethereum. Um, Whereas with chains like Starknet, obviously they can, that's written from scratch, and so they can just design that however they like. So, which is what we've seen with Starknet. So this is now available on Starknet. So this is a great advantage that we have when we're writing contracts. And it is also quite a good opportunity, I think, for in hackathons because there are so many extra features that this offers. There's quite a lot of interesting projects that you can do around ideas of account abstraction to do things that maybe where we have similar projects existing on Ethereum, but you can add extra functionality, extra flexibility by doing something similar on Starknet, but then using the extra features that account abstraction offers to us. So the basic idea behind account abstraction on Starknet is that rather than having everything just controlled by a public-private key pair, and that being the end of the story, what we do is we have a contract for our account on Starknet, and that contract is used when we are uh, creating transactions and when we're interacting with the blockchain. but because it's a contract, this means we can add extra functionality in there. We can add programmability to our account, which is not something that we could do with just the normal signature scheme. And so people have created these contracts to add extra things, extra features that are going to be useful. And this is what we're listing out here. So we have things such as social recovery. What this means is that if you lose your private key or it's compromised, then it would be nice to be able to do some kind of recovery. And with a contract controlling your account, we can do that. And this means that we could have different methods to do this. It could be that we would do that from a hardware wallet, or maybe the social recovery idea is that you would have trusted people or guardians who would attest to your identity and allow you and cooperate with you to allow you to change the key that is controlling your account. So lots of very useful ideas there, and particularly it starts to bring it brings a much better user experience to the blockchain, which I think you'll probably agree with me, is the user experience for people is not great at the moment. It has been improving, but it is still not great. So any steps in this direction really should be welcomed. Okay. Other things that you could use, you can add extra authentication around your account. So it's not, you could say that rather than just having the signature um, from your public-private key pair, you could have extra things that you need to do, such as having some, uh, sort of authentication application or Face ID, something like that. Um, a very nice thing you can do as well is to aggregate transactions together. So it's quite often the case, and certainly if you've been using DEXs and AMMs, you will have this uh, experience where you would have a drawback if you have to do multiple steps in order to do something that you see as a single transaction. Maybe you have to approve something and then do a swap, that kind of thing. And really, you don't want to have separate transactions involved in that. What you would like to be able to do is to aggregate all of that into a single transaction, which you can then send off, and it will be treated as one atomic unit. And so the idea behind multi-cores is that you can do that. You can aggregate what would otherwise be single transactions together into one overall transaction. Uh, Looking at the cryptographic side, the signature schemes that we have at the moment are not quantum resistant, which if quantum computers do become uh, feasible and are widely available and can do well and can implement things such as breaking public-private key pairs easily, then this could be problematic. But what we can do is with account abstraction is to say that we're going to use a different signature scheme and one that is quantum resistant, or maybe one that is just more efficient, such as the Schnorr protocol. So this really just allows us to choose whatever signature scheme that we want and then have that programmed into our account contract to specify that that's how we're going to sign for our transactions. Now, one of the biggest features, I think, is this idea of session keys. And I saw this being used with games a year or so ago, and it really was impressive how much better the user experience was. Because if you're wanting to play a game where every move that you make in the game requires you to send a transaction, and then you have to confirm that transaction from your wallet. Your wallet will pop up and ask you to confirm it. This is really going to spoil the immersion that you have within the game and provide a poor experience for you. So what we can do with if we have our account handled by a contract is to have this idea of session keys where we effectively unlock our account for a certain time period for the period where we're going to be performing the game, and then that we effectively get all of our transactions that are going to the game are then automatically confirmed for us. And I mean, that you can put all sorts of other pieces of security around it, so it can be quite secure. But it means you can just play the game much more smoothly with that. Other things you can do would be to, for your account, split it into various parts and put, a withdrawal limit on a certain part and have certain parts of a saving account and just split it up in any way that you like. And then one idea that is certainly been widely requested, I guess, is the idea of being able to pay for fees in any token, because it can be very frustrating if you want to do a transaction and you have to have the native token for that blockchain. If you don't already have some of that, even though you only need a small amount, you still have to go and get some of that token. And it could be that you're only getting that token just to pay for a transaction, that you don't want it for anything else, which can be very frustrating. So what this would allow is that you have a choice of how you pay for the transaction. Okay. Now, part of this, we're in a sort of a partway, uh, halfway house, I guess, with this, and some of this has already been implemented. But on Starknet, we've got this account abstraction there, and you can see a lot of this already there. And if you create accounts on Starknet, particularly using wallets such as Bravos or Argentax, then you will see all of this available. And there's more details there of example for the Visa are using to do payments more seamlessly as well. So there's a link to an article about that. Okay, so some of the functionality you get from Argent are shown here. I won't go into that, but you can have a look at their wallet, and same for Bravos as well. And certainly, if you're thinking about doing the tracks for those wallets, then you may well want to think about this and to look at the types of things that you can do within the account, within the contract that's implementing the account. Okay, so there's an example here of how you could go about this. So I've got some links there to uh, what a contract that implements an account actually looks like. So you can go through this. It has to implement various functions because these are then being used to execute the transactions, etc. But what some of the important things you need to think about and things like this within the storage, we have to store the public key of the account that is controlling this account. Sorry, the key pair that is controlling this account. So we still have this idea of a public-private key pair, and that private key is effectively controlling this account. And the public key for that is stored within the account. So the contract that implements your account knows which public-private key pair is controlling it because it has that public key within the storage of the contract. And you'll see if you went through the examples that I did when I was setting up the account using Starkly in the last couple of sessions, you will have seen how it was interacting with the key pair that we created, and then it was going to the network and creating an account on the network. Okay. And you can see here, yeah, when you deploy the account, when you create this account, you have this constructor which takes in this public key. So this is the key or the key pair that is going to be used to control the account. Okay. The way that this then handles transactions is via this execute function. And you can do, this is where we start to get the ability then to add all sorts of extra functionality in. And yeah, you can validate, you can add extra things in to validate the way that this is being done. You can there's parts here to check the signature. So this is details here of where it's checking the normal ECDSA signature. Um, and there's details about that if you're interested in that. But obviously, you could choose a different signature scheme and then implement that and check the signature using that rather than using ECDSA. So that's just a few notes about it. I've put a full example. Let me just check that's there. Okay. I've put the full example of that or of a very simple one into just there. So you can have a look at that. All right. So let's move on. So we'll talk about we'll go back to DeFi development and we'll talk about let me just close some tabs. We'll talk about Jedi Swap again. Now, I realized that last session, I'm sorry, when I went through, I was going through the guide for this, looking at the swap. I was looking at the version 1. So I'm sorry about that. We're looking at the previous version. I should have been looking at the V2 router. So this is if you want to look at Jedi Swap, this is the V2 router that you will be interacting with. And so typically what you will want to do if you want to do a swap, you're going to want to call a function such as this. So you've got a number of choices of the different ways that you can do the swap. But this is really one of the simplest ones. So this is the exact input single. So this is going to just swap directly from a pool. It is going to base this on an exact amount of tokens that you are providing. And then the amount of tokens that you get back will obviously depend upon the price. And this is where the concept of slippage comes in, and you have to take care of that. And we discussed that before. So this is really the simplest way that you can do a swap, and it comes back with the number of tokens that you are getting back. There's different possibilities that you have. You've got different functions, so you could decide rather than having an exact amount that you're inputting, you could have an exact amount that you want to get back, and therefore you have a variable amount that you input, etc. I think, yeah, you have the example details here of the parameters that you need to supply. So, for example, if you're doing the exact input, then the exact input single, then you can supply the details of the two tokens that you want to the token that you're providing and the token that you want to get back. So you need the addresses of those. The recipient here, that is going to be where the tokens will be sent. So it's probably going to be your address, but obviously you could make it a different address. You will need to pay a fee, so you need to provide the amount there. The deadline, as I spoke about last time, this is because the swap itself, you probably don't want this transaction to hang around, and there may be an amount of time past which this transaction wouldn't make sense. So you can specify a deadline of when you want this transaction to be invalidated. And then the next two parameters you pass in, the amount in, so this is the number of tokens that you are supplying. The amount out is the amount out minimum is the minimum amount that you're prepared to accept back. So you have to be careful about this. Obviously, this comes into the idea of slippage. So you have to make a decision how much flexibility, how much leeway you're going to allow there. Um, the price limit, this is to do with the ratio of the tokens. You don't have to, and that's an optional thing that you can put in there. Okay, so that's very simple. The sort of the simplest way of interacting with a Jedi swap. It's the same idea as you would get from I think Uniswap V2. So you can also look at examples of how those are implemented generally if you want to see that. Okay, but if you're going to do develop and you want to do some composability and pass and to call Jedi swap to do a swap, then these are the details that you would need uh, to supply. And then also, if you look back, I think in the previous workshop, I showed you or I spoke about the idea of the dispatcher within a contract, which is how you call one contract from another. So obviously you would need to set that up and use the address of the router um, to to do that to do that. Um, okay. All right. So that's some details, but you can go through details there, and there's details about how to make a swap, also how to add liquidity. If you rather than just supplying a token and getting the other token back, if you want to supply both tokens to add liquidity for the pool and to get liquidity provider tokens back, then there's details of how to do that. Okay, so those are the notes that you would generally want to be looking at. Now, another track that uh, I think people were, oh, sorry, the question on Slido, how do you get the swap fee? It's usually a fixed amount, it's usually something like a fixed amount of a sort of a third of a percent or something. I can't remember. It will be, there'll be details about that for the particular AMM. They will say what the minimum fee is going to be. Um, so another track that people were interested in was Pragma. So I'll just speak about this. So I've got a link there to the docs. Let me, whoops, yeah. I didn't want to do that. So yeah, they've got a book about that. Obviously, you're going to want to look at the Cairo 1 version there. Sorry, I um, need to go back. Okay. So, so a little bit of detail about what Pragma is. So, it's implementing the idea of an oracle, where because in blockchains generally we have this problem that there's data that we need, but we cannot get this directly from a contract. A contract is really kind of sandboxed. It can't make calls to the outside world. Um, and this is for security reasons, amongst other things. Um, and so the way that if we need data in our contracts, such as if you wanted to get the price of a particular token, what we have to do is to get a third party to send that data on chain for us. And this is what projects such as Pragma allow or will do for us. Uh, so there's details here of how they work generally. So this is split into two parts: the off-chain part and the on-chain part. So off-chain, we will have a publisher who is publishing details, publishing prices, some kind of data, and pushing this on chain. And there's various bits of administration about this and security around this and getting these details registered. But the way that you use this is that you would have an Oracle contract and there would be a proxy to that. And your where your project fits in is that you would be the protocol that is receiving this data or that wants this data that the Oracle is providing. And it can go to the proxy contract for that, or also to this compute engine, which I'll come on to in a second. Um, so uh, the Oracle implementation contract in its proxy is used by the protocols. So it's the way that the publishers and the receivers of the data, that's where they interact at the implementation contract, or it is proxy, and it has various pieces of logic in there for storing the data and aggregating data because with an oracle, you're most likely going to want to have multiple sources publishing data. So as you can see here, you may have a variety of different chains or data providers who will be providing prices. So, for example, if you wanted the Bitcoin price in USD, you may have multiple people providing that. And what you would like to do is to then bring those, they could be pushing those together and publishing those prices. And what you want to do is to aggregate those and get a reasonable value from those. And what Pragma does is to do a process on chain, which takes all of these multiple sources and aggregates them. And what it does is to take the median price. Although I think you do get options about how you want the aggregation to work, but I think that's the default one. It would take a median price amongst all of these different data sources. So this gives you some security. So if a particular source is providing a price that is obviously wrong for whatever reason, then that wouldn't affect your data too much. Okay. Now the compute engine is taking this a step further in that it allows you not only to get the details that are published from the publishers, but also it will can then do extra computation on data. And so they provide some useful metrics that people commonly want. And so they have things such as the volatility and a time-weighted average price. So these are obviously very useful in finance, and then a yield curve again useful in finance, which gives you a kind of a zero coupon yield there. So just some extra functionality that the compute engine can provide for you there. Okay. Now another thing, now not related to finance particularly, or prices, but something that is difficult to do within blockchains, but is very widely needed, is the idea of randomness. And I mean, if you think about something like a game, you often want some randomness involved there. And so a way to do this securely, or a way to get randomness into your contract securely, is to get this from an oracle. And Pragma provides this for you. And they have what is called a verifiable random function, which is a cryptographic function, which provides random values, but you can check that this is being done correctly. You can check that these values are being computed correctly. But it's a way of doing this. And although you can check it, you cannot then forecast what the next random value would be. So it's a secure way to get some randomness. And there's an example. Let me check that. Um, yeah, there's an example here of receiving randomness in a contract. So if you are developing a contract that needs randomness, here's an example of how you can do that um, within your contract. So you can see here they're storing some last random value there, and they've got a link here to this the contract. Is that the correct one? But to the various contract addresses anyway um, to get the randomness. Okay. So yeah, so if you're developing something like that, you may want to have a look at that code if you need that kind of detail. All right, let me move on then to games development. So I think well, this is certainly yeah, we certainly have some tracks involved with game development, and I think this is an area where StarkNet is doing particularly well, and there's a great deal of uh, development going on. There's lots being done, lots of projects, lots of really interesting things happening. I think generally the games on chain, the area is moving very quickly. Um, but StarkNet or Starkware seem to have sort of done well in sort of building this out quite nicely for developers and providing resources for them. Now, this one of the starting points of this was a game called Dark Forest, which was built. It was a an idea that had this thing called a fog of war. So the players within the game had very limited information, but they used um, zero knowledge proofs to prove that the moves that people were making were being done correctly, but using the zero knowledge aspect of that to ensure that details about the players was not public, was not being given away. Um, yeah, Starknet have uh, provided lots of resources for this. There's some details about um, uh, yeah, some of the projects involved, and I just wanted to highlight one of these, which is Madara. I spoke about this before, but this allows you to spin up your own chain, your own layer three, which can then interact with the layer two, and this is quite a common idea that people have. They if to create a chain specifically for games, for example, or maybe for a particular game, and you'll have heard of the idea of app chains as well. So one project that is really leading the way is called Dojo, which is a game engine. And so this is a framework that really is providing all of the pieces that you need to write some very interesting games. And it also supplies what are called or allows you to create what are called autonomous worlds. Now, I'm not going to um, say a great deal about autonomous worlds, but this autonomous worlds is an idea. It's not specific to StarkNet, but it's being they're being implemented on many chains. Um, but it's a something that people are there's a lot of appetite for. A lot of people are getting very motivated about this, and it's a kind of an open standard for the way that games are being developed. And it it depends upon uh, some concepts, such as this thing called ECS. So this is a particular pattern that allows you to create games or autonomous worlds in some way. And it is an architectural pattern to break this down into some manageable concerns. And so the ECS, the initials stand for entity, component, and system. And of those, the entity is would be a distinct object. So that could be a particular player or some kind of actor within the autonomous world or within the game. But that is sort of held separately from other details of say, their behavior, for example, which is handled with what is called a component. So that is where we add a component to an entity to show the behavior of that entity. But because the entities will have similar behavior, what we would do is we could create components that we can reuse and attach to multiple entities. And then we need something that is going to allow us to control our world generally or to provide general services. And that is the idea of the system there. And so all of that comes together in this kind of diagram here, where You have uh, entities interacting with various components, um, and that could then end up uh, being rendered into some kind of UI, um, or or you could just be interacting with the components, and then that will be interacting with the system overall. Now, if you're building a UI, there is a project called Bevy that will help you to do this. This is just a little bit of code here to show you what this looks like. Let me show you that link. Uh, so this is an example here. It's a simple Bevy game which shows you um, uh, the idea of how you can set up sort of the rendering of the game and set up windows for that via the idea of these things called plugins. Um, Now, I don't have much more I can say about the sort of the Bevy side, but there's links there if you want to find out more about that. Okay, so that's talking about the ECS idea generally, and then Bevy, which you can use then to create some kind of UI. But how this is done in StarkNet or how this is done in Dojo is shown by this architecture here. So you have here we have the idea of components and systems within a particular world, and then Dojo would set up and allow you provide a framework for all of these, and then it allows interaction via SDK, so you can use that to interact with all of these parts. So Dojo is a way. So Dojo is an implementation, following this architectural pattern. So you can see the ECS being done, but it adds other things. So the idea of making queries and the general, and then bringing everything together into a world. And then it also has a number of tools that can help you build all of this out. So we have this tool called Sozo, which is really kind of like Scarb, I guess. It's there to act as the way of giving you an interface that will allow you to interact and build projects. There's a link there to the overview in the Dojo book. I'll show you an example in a second, but I'll just go through some other parts as well. So Katana, I've already mentioned, which is a local node that you can use. This is also used in Dojo as well. Um, and then Tori is used as a way to because with Dojo you have this ability to do querying. Tori provides that layer that it does the indexing of all the details from the world that you can then interact with. Okay. Uh, and then doing that, or in order to do that, you can use the commands API. I'll show you details of that within the Dojo book here. So what this allows you to do it really sort of provides shortcuts for you when you want to interact with your world. And you have these commands. They're really like macros. So you have these things like get, which will get details that you would want, and you have set. So typically, oh, you have well, other things like emit as well. But typically, what you will be doing would be to be getting details maybe about your particular player, so their location or some aspect of their behavior, and then you could then change that. Maybe the player would want to make a move, so you would change the details, and then you can use the set command to then write that back and show um, sort of update the game with the way that the player has moved. And then we've got other things you can do, omit as well, and delete. pieces if you don't want them. Okay, so that's the commands API. Um, uh, there's also the easiest way to find out about this is really to go through and follow their tutorials. Installing Dojo is very easy. So you do the usual curl and then Dojo up, and it will bring up something like this. And there's links then as well to the various parts you may need. Now, I had a sorry, an example. So I created here a a, a boilerplate project using Sozo. So I just did Sozo and then what was it? I think it was just new game, and it provided this for me as a boilerplate. If you it's worth looking at the TOML file, the config for this. So it brings in the Dojo dependency, as you can see there. Um, it's also pr providing the compilation target there. So it's a special target for Dojo. And then there's this is set up here for interacting with Katana, as you can see. So it's assuming you've got Katana set up as a running locally that particular port, and it gives you an account for that. It's also got further details about Dojo and the the details of the tutorial as well. So if you want to try it out, I would recommend that. It's just with Sozo you just do the usual thing of building, as you can see there, and you can test. The actual code I've got is very simple. There you go. It's passed its tests. So the code I've got is I've got the idea of a player here with having a position, um, as you can see there, and then you can define here how the player can move in different directions, and you're giving these particular numbers, etc. But you can have a look through all of that. It's a way of doing a very simple model. Okay. All right, so that's that. I'll just go through some of the other games that have been done on StarkNet because some quite interesting ones. And it's worthwhile if you're thinking of, writing some games. It's worthwhile having a look at them. There's Loot Survivor. Obviously, Loot was very popular. There's a real trend about that at one point. But you can see here, this is. Oh, I've got some nice music. Um, okay, I'm going to kill that. Um, yeah, this was very popular at one point. And this is the version on Girly, so you can have a look through. There's a link there to its repo as well, so you can check out how that's been implemented. Dope Wars was a very popular game generally, I think, back in the day. And so that's also been implemented now on StarkNet, as you can see. So uh, this has been implemented. It's called Roll Your Own on. It's been implemented on StarkNet using the Dojo engine. So you can try that out. You can see here, and you can check out their code. There's a link there to Roll Your Own. This next one, this is a just some details that one of my ex-colleagues did about a particular game. You can have a look at. This was done during a previous hackathon. There's the very old idea, the lunar lander, that's now available also on. Oops, I've lost the tab. Um, Yeah. Also on StarkNet, if you want to have a go at that, yeah. Again, you can see um, using Dojo, so and Katana and Sozo, etc. Um, uh, there's details about that. This one is interesting. Drive AI, I think. Yeah, so this um, uh, is an interesting game in that it things are being controlled by a neural network. Um, but again, it's been built by using Dojo and then Bevy for the front end here. What's also interesting about it that I wanted to show you as well is that for um, the AI part and the machine learning part is using Orion. So there is also a track if you're interested in the AI side, then there's also a track about Giza, and that is or part of that is or from that's come Orion, and what Orion provides is a um, a framework which uses the this I think it's pronounced Onyx runtime, and this is useful because this is a framework that I think is used generally in machine learning. So if you look at the sort of widely used tools, um, such as TensorFlow, etc., I think those yeah, or PyTorch, then I think those are will provide information in this particular format. So this is a way that you can then sort of standardizing the way that we are doing machine learning, but in a alongside zero knowledge, and here particularly using Starks. So if you're interested in the Giza track, then check this out as well. So this is from Giza Tech, as you can see. Um, yeah. So that was the game that was built using their AI. There's also another example here, this chess, um, which is uh, this tutorial. Again, it's from Dojo, so it's following the ECS the pattern, but it takes you through how to do all of that in Dojo. So you can, if you want to try out building a game, then that's a good tutorial to start with. Okay. All right. Just quickly talk about layer threes as well. I mentioned them briefly, but just say again, the way that blockchains generally seem to be where we're heading, I think, we've implemented layer twos and they are becoming quite successful. They're really sort of settling in, and obviously Starknet is an example of that. But then people start to think we could sort of follow up this idea of um, doing roll-ups, and so we can do this idea of fractal scaling, and we can get layer threes, and that's what we are seeing. So the layer one, that's Ethereum, that's for security. Layer two, that is will have general applications, maybe more DeFi, but it's relying upon the layer one for security. And then layer threes, we can make these very specific. So we can set up a layer three, maybe to focus really on writing games. And you can adjust the parameters of the chain to suit that. So you can set the block time or the transaction fee so that it will be appropriate just for games. And if you want to do that, or a simple way to do that with Starknet is to use Madara. So there's a link there. So it's an easy way to spin up a layer three, and then you could use that to as a chain for on the top of which you can build games, for example. So yeah, there's details or ideas around that there. And again, you have the possibilities of uh, communication between layer threes as well. So it could be that you would have a number of layer threes communicating with each other and then providing updates to the layer two. Okay. But the idea behind this is that you can further reduce the costs of transactions, and also potentially the latency by providing or by creating a layer 3. Okay. If you want further resources, then there's lots of links there. Also, some interesting articles. So, Xerox Park are a project that are doing all sorts of interesting things in this area, very heavily involved in autonomous worlds, but also in ZK generally. Guilty Gyoza as well has written a number of games, so all sorts of interesting things there if you want to read about it further. And there's an example here. This hackathon, this is over, obviously, but you can also have a look at the types of things that came out of that if you're interested in ideas around game development. Okay, so that's everything I wanted to talk about specifically, but I just wanted to go back and talk about the onboarding task because we have a little bit of time left, and I'm aware that not everybody was here when I originally spoke about the onboarding task. So I'll go through that again. Let me put the links in chat again so that you have those. So if I can, well, I think I've closed it, so I have to go back. There we go. So, the onboarding task. So, I'll just describe this again so that just to make sure everybody's happy with this. So, the idea, what you need to do is to write a contract and deploy that to the Gurley test network. And then once you've deployed that, then you need to show that you've done this by registering that contract address and associating that contract address with your Discord ID. Now, in order to do this, obviously you'll need all of the projects installed that we looked at in the first workshop, such as Scarb, etc. Also, you will need to get a wallet such as Argentex or Bravos, and you'll need some test ETH as well, which you can get from the faucet. Now, the contract itself, the one you have to write, it is very simple. There is not very much to it. It's a voting contract. It's not perfect by any means. I mean, there's lots of flaws with this design, but I wanted to make it as simple as possible. So you really have only a couple of functions that you need to implement, and these are shown by this trait here. There's a link there to that in a gist. So the idea is that one function allows people to vote, and so that vote will then get counted. And there is only one proposal, so it's not a case of having a choice of votes or voting for or against something. You just vote, and then that means a vote has been added to the and that adds to the count for or in the contract. And then we need a function to get the vote, so this gets the total number of votes that have been cast. So that's the trait. So those you need to implement those two functions. The other thing you need to implement, though, is that each address that is calling this is only allowed to vote once. So you need to check that before you add to the votes. And then when a vote has been added, you should emit an event to show that that vote has been cast. You don't have to add any other information into the event. It's sufficient just to emit an event. The get votes function, yeah, that should give the total number of votes that have been cast in this contract. And there's no security involved. You don't need to think about any of that. Anybody can call either of these functions. Okay, so from a design point of view, it's not great, but yeah, I just want to keep it simple. So what you need to do, once you've written it, then you need to deploy it to the Gurley test network. And once it's deployed, take a note of the address. Now, the easiest way to interact then is to use Voyager. And so once you've got the address, then what you need to do first of all is to transform your Discord ID into a number, into a felt 252. So if you go to Voyager and go to under developer, menu, there's utilities. If you click that and then scroll down, you'll get this, which allows you to take a string and convert that to a felt. So put in your Discord ID here and record the output, the felt output that you get from that. Sorry, whoops, oh, wrong tab. Once you've done that, you need to go to the registry contract, which the address of that is here. There's a link to that. So you go to the registry contract on Voyager, go to the write contract tab. You need to connect your wallet, and then you want to call this register contract function. So this is how you show that you've deployed your contract to the testnet. So within that function, you put in your Discord ID as a felt, so it has to be an integer. Put in the contract address, the address of the contract you've deployed to the testnet, and then hit transact, confirm the transaction within your wallet, and then that will let me know that you have completed the onboarding task. Okay, so that's all you have to do. I think it's quite simple. It's really just there to make sure that you've got everything set up, that you're able to deploy a contract to the network, and to write a simple Cairo contract. The deadline for this is here, so 1700 on the 27th. So just to be aware of that. But just to say finally as well, the next thing's coming up. So this is the third workshop from me. And then on the 26th, that's tomorrow, you'll have a session from Starkware about Cairo. So that will also help with your task, and then you have to submit your task. And then on the 28th, you can start forming your teams. And then we have the official opening session as well. And yeah, the registration's closed for your teams then. And on the 29th, the hackathon begins, and plenty more sessions during the hackathon there. And yeah, the final voting begins on the 17th, I think, and then we get the winners announced after that. So that's the timelines. I think you've all got the details here from Taikai about that. So I think you've all already had those. All right, so that's everything that I wanted to talk about. We're a little early, but yeah, that's everything from me. It just remains then for me to thank Laurence and Taikai for and to Starkware for all of their organization and their involvement with this hackathon. And to thank all of you for joining these sessions. I hope they've been useful for you and provided you a good basis for going on. I look forward to seeing what projects you come up with in the hackathon. I'm sure you'll have a great time there. Please make the most of it. I gave you some tips in workshop 1 about hackathons, so please have a look at those. But yeah, make the most of it. Write some really good projects. I'm sure you will come up with some great ideas. The question about can I submit one project? You'll have to ask the Taikai team, I think, about that. I don't know the answer to that, so please direct that to them. But yeah, other than that, I look forward to seeing what you come up with. I'm not a judge or anything like that, so I'll just be looking once the hackathon is over to see what people have been written. But yeah, I'm sure you'll have a great time. I'm sure it'll be a lot of fun. You'll learn a lot of things and come up with some great projects. So best of luck for that. Thank you again to everyone for attending. Oh, right, there you go. There's the answer. You can only submit one project. Okay, yeah. But thanks, everyone. Thanks for attending. That's the end of these workshops. And yeah, best of luck. And I hope to see you all again. Thank you. Bye-bye.